And the person who got credit for a lot of what turns out to be Mary Spear's work is John Tukey. And I would say that John Tukey, until very recently, was my favorite statistician, and he still might be number one. So Tukey was this kind of amazing statistician who rocked the boat by saying we needed to focus more on data analysis. And he wrote this book called Exploratory Data Analysis. The abbreviation for that is EDA. And basically he said, you shouldn't just start modeling things. You should make a bunch of summary statistics, you should make graphs, you should try to understand your data. And he has this quote that I love, the greatest value of a picture is when it forces us to notice what we never expected to see. So it's not just trying to confirm what you were expecting, but it's showing you something new. And I think that that's really valuable. He really gets credited for the box plot, although he obviously didn't create it. And I think that history is being reevaluated there a little bit. And so, as we've seen, the past few folks here have been doing hand-drawn data visualizations. Interestingly, Tukey lived long enough that he was a huge proponent of using the computer in statistics. He was a really early proponent, and then he worked on that throughout his life. So this is going to feel like a jump in history, but he worked on this computer system called Prim9. And I've put the video in our playlist. I wouldn't expect you to watch the whole thing. It's pretty long, but we could watch just like a little segment of it. So in this video, Tukey is using a light pen, which is a way of direct manipulation on the screen. It's kind of like my iPad pencil, and he's using that to interact with data which is in 9-dimensional space. And what he's doing is he is moving through a variety of projections down into 2-dimensional space. And you can it makes it feel like it's a projection in 3-dimensional space because of the way that the data is moving. You kind of get this animated parallax effect where you can kind of see the data as if it was projected from 9-dimensional space down to 3-dimensional space. And he's able to find these clusters of data in 9D, which I think this is physics data. Physicists knew about these two clumps, but they were very hard to visualize because of how many dimensions were in the data. So my goal, I always say, is my goal is to be better than John Tukey with a pencil when I'm using the computer. And then because Tukey was also an advocate for computer-aided visualization, now I'm also like, we should try and be better than John Tukey with a computer. And interestingly, some of this stuff has not been well implemented even to today. I think this work is from the late 60s, early 70s, and it's not totally accepted into the work that we use today. Right around the same time as John Tukey was Jacques Bertin, who wrote The Semiology of Graphics. He was a French man, a cartographer and theorist. And again, he came up with all these different visual attributes and the idea that that's how we make visualizations, is we try to map variables in the data to visual attributes. He also was doing a lot of hand-drawn data visualization. He had some really unique ways of doing data viz. I was at the IEEE visualization conference in Paris a few years ago, and I took this photo. They had an exhibition of his work, and I found these maps really compelling. But perhaps more compelling is this idea that he came up with called a Bertin matrix. And it's basically a way of sorting and clustering data, but it was pre-computer. So what you see on the left is a physical matrix, and it's made out of, it's sort of like little beads almost, and then there are skewers that go through in each direction. And what you can do is you can take out some of the skewers so that you could move around a row or a column in the data set so that you could look for some cluster in the data. So it's this very interactive process to find the clusters. And then what you see on the right are photocopies. So they didn't have a version control system, and you didn't want to like just leave that matrix in the state that it was in, because it's useful to be able to move it around and you want to be able to reuse it. So his students would take photocopies of the physical matrix so that they could keep track of the different stages. So that's what you're seeing there. So again, this is trying to do some interactive data visualization or data wrangling before computers were really good at doing that. Next up is Bill Cleveland. Bill is still alive, and we're going to read some of his book when we get a little bit further on to graphical perception. Bill was a professor of statistics at Purdue and is maybe most famous for his research about the effectiveness of different types of visualizations. So Bertin told us that we had things like color and length that we could use. And Cleveland and McGill did this famous study where they looked at the error rates of people comparing based on position on a common scale, I think position on unaligned scales, I forget what type 3 position is, length, and maybe this is aligned and unaligned. And then angle, that's like what you would see in a pie chart. You'd be making the guess based on angle. So this chart, the sort of like length versus angle, this is why statisticians argue against pie charts, is because of this study, which I believe was done in 1984. It's been reproduced a little bit more recently, and it seems like that persists, at least with pretty educated white people in the United States. I think that there's variability depending on your education level or your background. Some people are more accustomed to looking at things like pie charts. So this looks like a big jump ahead, and it is. This is very modern. This is from Plotly, which is an R package that was developed based on a JavaScript library, and Carson Sievert created the package. But I'm using it to just show you the idea of brushing and linking. So once we were able to move away from doing everything on pencil and paper, we were able to use computers to do some of our analysis, then one of the really powerful things was being able to say, okay, let's have multiple graphs that are linked together, and then when you brush over them, you highlight some portion of the data, you see that same portion being highlighted in the other graphics. So it's connecting things together so that you could maybe think about a bunch of variables or relationships between variables. Again, it's sort of thinking about in that higher dimensional space, but it's a different way of visualizing it. So one implementation of that kind of brushing and linking was from this program called XLisp Stat, which was by Luke Tierney. Luke is also still alive and working. He is a professor at the University of Iowa, and he's done a lot of work on R as well. So this is kind of a precursor, but he developed some work that did brushing and linking interactive graphics that are more modern. Then we've got Leland Wilkinson. Lee is also still alive, and he is a statistician and a software designer. So he's worked on a bunch of different pieces of statistical software. He was at Tableau for a number of years. He's now at H2O.ai, which is a machine learning company. But he's maybe most well known for this book that he wrote called The Grammar of Graphics. And in The Grammar of Graphics, he outlines this idea of a layered way of sort of conceiving of graphics. That you start with the data, and then you layer on top of that aesthetics, things that you can see. Then you layer on top of that geometries. You layer on top of that facets, statistics, and then perhaps last coordinates. So this was not based on a particular type of software. It was more of just a theory of how you could conceive of graphics, and it made the field a little bit more academic. So if you know R, you may know that there are a bunch of different graphics libraries that have existed in R. So there's base graphics. There's lattice graphics, which uses a different syntax and has different defaults. And then the most popular form of graphics now is ggplot2 graphics, which have more thoughtful defaults that are based on things like related to Bill Cleveland's work about perception and all sorts of rules like that. And ggplot2 was written by a statistician named Hadley Wickham. It was part of his doctoral dissertation, and it is an implementation of the idea of the grammar of graphics. That's why it's called ggplot, grammar of graphics plot. And it's called 2 because it's the second version that he came up with. He made the first version, and he decided that he didn't think that the API, the way that the code, you'd interact with the code, was quite right. So he wanted to make a second version. He didn't want to break it for his, I think he had 100 users at the time. So he said, I'm going to make a new version of the package. I'm going to call it ggplot2 because it's the second version. And now no one uses ggplot. Everyone uses ggplot2 and millions of people use it. So it's kind of funny that that's how it ended up with that name. And Hadley works on all kinds of things related to data science. He's now, I think, the chief scientist at RStudio, so he's done a bunch of cool stuff, but perhaps most relevant to this class is the graphic stuff with ggplot2. Another contemporary implementation of the grammar of graphics is d3.js, which is a JavaScript implementation of the grammar of graphics, and this was created by Mike Bostock. And Mike also was involved with Jeff here with doing a crowdsourced replication of the Cleveland McGill study from 1984 to see if it held up in terms of the perception in the modern era. And we'll talk about that more when we do perception. So I think my last point is just like things are accelerating. It seems like we've covered a huge amount of history here, and I think that with the inclusion of computers in graphics, we're able to do all sorts of interesting stuff. So I've included one of the screenshots here is of, I think it's Vega Lite, which is a way to make graphics in a sort of graphical user interface, but have them be reproducible. So this is a reproduction of Menard's famous graphic about Napoleon's march on Russia. You could think about like augmented reality or virtual reality ways in which that could be used to visualize data. We'll talk about how could you tasteify data or smellify data or sonify data. This is Nathan Yao's multivariate beer that we'll talk about later in this semester. And I'm not sure exactly why I included this as Plotly. This is another recent tool. Like I said, there's an R implementation of it, but you can also just use it on the web. So I think that we're kind of democratizing some of the data science stuff to make it easier for people who aren't computer experts to get involved with it. So that's just a brief history of data visualization, and we'll get more into the details next time.